All right, so frames and machines. So far we've been working just on trusses. And trusses have the distinction of being made up of only what?
Two force members.
Only two force members. Okay? And while trusses are awesome, and they're all over the place, they're wonderful inventions, turns out we can't always put the loads right on the joints. We can't always make a truss. Sometimes we're just going to have beams and things. And that's okay, but we need to be able to analyze them. Okay? Frames and machines. Thank you. Frames and machines. All right? So that's where frames and machines come in. And the trick to frames and machines is we need to draw really good free body diagrams. Okay? So the classic example of a frame would be something, and there's one in your notes, like this. Sure. Maybe we make an A frame. A, B, C, D, and E for me to stand on. Walk the plank, you filthy varmint, right? Maybe we became pirates. So now, is this are there any two force members in this? No, no two force members. Okay, because member AC has a pin at B, member CE has a pin at D, member BD me, right, has 3. Sorry, I didn't have a letter on it, so it had to be BD me. Okay? So this is a frame. It doesn't move. A machine, the classic example. Can anyone tell what I'm drawing yet?
Squiggly. Hammer. Screwdriver.
You're in the right genre.
Wrench.
Ah,
Wingtips. Scissors.
Oh, it's a wrench or a bolt cutter or something or a clamp or.
pliers.
Okay.
I feel like everyone was wrong there.
No, Jordan had vice grips. Like, he knew I was drawing something clamping. I think he did a good job. Okay? And so, right, so pliers, these things move, and essentially machines just do force multiplication. Right? So if you're using pliers, you should know, now that you've taken this class, that all that's happening here is that we sum the moments about this point. And I have a big lever here, right? So big L, and I have a little L here, right? And so when I squeeze with 20 pounds of force, right? Maybe I could squeeze that hard on these. That because this is maybe, oh, I don't know, 6 times as big as this L, that the force that the bolt experiences is going to be 6 times 20, which is 120 pounds, right? Okay, so this is a simple machine. This is a frame. This is a machine. Okay? The distinction isn't super important, but what you should notice is, hey, there's no two force members in these, right? So if I looked at this guy, it's made out of 2 links, but neither of them are two force members because there's a force applied here, here, and there. So they're maybe a 3 force member if you want to call it that. Okay? Any questions about the difference between a frame or a machine?
Not going to frame it differently.
I'm not going to frame it differently, no. So if you're using a pair of pliers, would it matter, or let's say cutters, anybody, side cutters, would it matter whether you put the wire you're cutting out here or in here? Which is better? In here is much, much better. Why? How many times better is it, according to my drawing? many times better, right? Can you see that? Because what I've done is I've taken the length, let's put some numbers on it. Let's say that this is 0.5 inches, but to the tip out here, let's say it's 1.5 inches, right? I just have a 1 inch long cutting blade. So this is 3 times as much power if I put it down here as if I put it out on the tip. Did you get that? 3 times. No one cares. You should care. This matters.
It's not like an order of